Now let's examine Yum configuration. Yum is a means of providing updated packages, RPM packages, to your Red Hat Enterprise servers. Let's return to our notes and just label this section Yum configuration. And it features, as mentioned, the ability to centralize packages, in particular updates. And this is all built in, but we need to configure it and make it available. There is a package, so let's label this section installation known as create repo that we need to install. So install create repo star RPM on one of your Red Hat Enterprise servers. The create repo package includes the necessary tools to generate the metadata for the Yum repository based on wherever you've placed it in your file system. So we're going to do a few things here. We're going to install create repo on our local system, download the RPM packages from the 5.1 build to a directory, create the metadata, and then re-upload the packages to our web server. And then we'll be able to configure our Yum client to get the updates. So, first step is to install create repo RPM. Let's navigate to Firefox and search for create repo. There's the package. We'll copy the entire link using copy link location and then install it locally. Of course, since we know a little bit about RPM now, we can RPM query all grep create repo to see if it's already installed, and it's not. So then we'll RPM UVH or IVH the full path to create repo. Now create repo is installed, and RPM query list create repo will reveal the contents of create repo, which includes the main utility create repo, which creates the metadata necessary for Yum clients to be able to download updated packages. But we're not done yet. We need to mix and match things. We need to bring the packages into a centralized directory or into a directory structure, either from the DVD or from a remote system using, let's say, LFTP, generate the metadata, and then re-upload the packages, or turn on Apache on our local system. Either or will do. But our intent is to serve the Yum package repository using HTTP, and since we've yet to look at HTTP during this edition of Linux CBT on Red Hat Enterprise Linux, we'll work with the current running version of Apache on the SUSE server, which is why we're uploading and downloading. So, create repo is installed. Now we need a directory structure that makes sense. We're going to create a directory structure which matches that on the remote system. So let's look at that. We'll SSH as root over to 192.168.75.100. This is the SUSE box. And we know that the directory structure is as follows. Serve www.linuxcbt.com RH5, beneath which we have the i386 server subdirectory. We're going to create a directory known as Yum, and in it is where we'll eventually upload all of the RPMs with the new metadata. But we also need to create this structure locally. So locally we want to create this directory structure just to make things equivalent. And we also need to ensure we have enough storage, and we do, 31 gigabytes, so we'll make directory serve www.linuxcbt.com. We're just matching them up. You don't have to follow this directory structure on your system, just as long as wherever you create the repository, you ensure that it is set up and accessible via a protocol such as HTTP. So since our HTTP server serves out of serve www.linuxcbt.com RH5, at least in the case of the repository, that's why we want to just make it the same. So now we have the full structure, and we can navigate into this full structure by changing directories into it, and then download all of the RPMs from the website into that directory, then create the repository, then re-upload it to the server. So we'll have double data, but nonetheless, it'll work. Let's use LFTP to connect to this path. Now you'll see all the RPMs. All we need to do is get these RPMs across the wire using mget star RPM. This will pull everything locally into our directory, and momentarily we'll be able to run the create repo. Again, this is the long way. If you have all of your RPMs on a server, or if it's on a DVD, you set up a directory structure with all the RPMs, use the create repo utility, it creates a repository, and then so long as that directory is served by HTTP, you can configure your Yum clients to download from the location. So we install create repo. Next step, so we'll include this as installation and setup. The next step is to set up directory structure. The third step is to run create repo against that directory structure, which should still be in memory, and it is not, so only a portion of it is, and that is serve www.linuxcbt.com rh5 yum. Once the metadata has been created, we'll publish the Yum repository using HTTP, however you intend to do so, either locally with a Red Hat system, remotely with an IIS server, doesn't matter. And then fifth, configure Yum client to use HTTP to fetch the RPMs. So these are the steps that you need to cover. Again, there may be more or less depending on what you're doing, but the bottom line is you need to install create repo on a Red Hat box, set up the directory structure either from DVD or from wherever you have your RPMs, the latest version of the RPMs, run the create repo against that directory structure, and then publish the directory structure using HTTP, followed by configuring the Yum client to download packages from that directory structure. Let's see where we are with the download process. We should be able to confirm locally in a separate window. Let's find a free window here, the current status. We'll log off LinuxCBT serve 4 for now, then navigate to serve www.linuxcbt yum rh5, that is yum. And so far, a lot of files have been copied. DUCH will tell us, and it's 1.1 gigs. The total is over 2 gigs, so we'll just wait it out. And just a quick note regarding the yum.conf file. We can jump to that step at this stage, step 5. That file is located in etc, and it's known as yum.conf. It contains very few directives, of which the important one is the base URL directive. So let's ensure that we're root because we need to be in order to make changes to the file. We'll navigate to etc, then modify using the nano editor yum.conf. And there's a repos directory as well. This is where you can put your repositories. Yum supports more than one repository when searching for packages, and will handle dependencies as well as version conflicts. So again, the base URL, that's a directive that's important in order for us to get access to the repository. So for now, our Yum repository, we'll just include a comment included as our first repository on the SUSE box. And the directive is base URL, setting it equal to HTTP 192.168.75.100. This is where we'll publish it, rh5 yum. So Yum will know to search this repository. Also, when you launch the add remove GUI, the add remove software GUI, it'll check the Yum repository. So this supposes the repository is up and running. So on the remote system, we need to be sure that that directory exists, Yum, but it currently contains no files. And the RPMs won't be changed, so you can always save time by copying the RPMs from i386 server and then copying the differences, the metadata files created by the create repo process into that Yum directory. That'll save you some time, definitely. instead of copying the RPMs, because create repo doesn't actually change the RPMs. It just needs to know a full list of the repository, of the RPMs in the repository, to generate the metadata. Let's see where we are. We will use one of these spare windows. This one should do. And we'll change to serve www. And in fact, we should just also get our yum entry and paste in our notes. So to update the yum conf, we made the following change. That takes care of step 5. Step 4 is already taken care of because serve www.linuxcbt.com is the web root on our SUSE box. So we need to execute step 3. We already set up the directory structure, and that's serve www.linuxcbt.com rh5 yum. That's already taken care of. We've already installed a create repo package. So now we just need to run the create repo package and upload either the full directory or the differences from the local directory to the new HTTP directory on the server. Let's take a look to see where we are. We'll navigate to serve www.linuxcbt.com rh5 and then duch yum. Well, we're now up to 1.9 gigs, so we're making progress. And just be sure that you have enough space. We should just note that in our documentation. Ensure that about 3 GBs are available for the yum repository. It's really 2-point-something gigs, but roughly 3 gigabytes will cover your tracks, and will also cover you if you download packages from the Red Hat network. Now this yum repository again can consist of RPMs from various sources, again including the Red Hat network, so you could use one subscription to publish updated RPMs into your local yum repository in your network environment, and then allow your other Red Hat servers to benefit from that local yum repository. Even if you had a subscription for each Red Hat server, it would be less than ideal to have each of them connect using HTTP to Red Hat servers for bandwidth reasons. So to conserve bandwidth, download the RPMs once and then set up a yum repository. Let's consult the shell to see if we've made any progress. We're up to 2 gigs, so we still got hundreds of megabytes to go. Let's see where we are now. 2.4, we're almost there. Again, this is being pulled using LFTP with the HTTP protocol across 100 megabits per second backbone. Let's check again. Now we're at 2.5 gigs, we should be finished. And indeed we are. So let's exit this LFTP session. It's 2.5 gigs, it hasn't changed. Now we need to create repo. That's a step where we indicate the full path. We'll copy this command, which will create the meta files. This is scanning through what appears to be just under 2160 packages. Again, the packages will not be changed. In fact, from the other shell, if we lsltr the yum repository, we'll see that the packages are intact with different timestamps, but a new directory, repo data, has been created. We're just over the 10% mark. And we'll continue to elapse the progress in the interest of saving time, so we're over 20% of 2159 packages. Again, the packages will not change, just metadata will be added that we can then transfer to the source server We could even use the original source repository, but just to keep things clean, we've decided to double up on the repository. But we could have used on the SUSE box, for example, the i386 server location. That's this location that we've been accessing thus far. It could serve dual purposes for Yum as well as for general RPM installations, but if it is a Yum repository, then there's no need to RPM followed by, or execute RPM followed by an RPM HTTP URI. We could simply use Yum space install space the name of the package, and Yum would go about finding it. So we're just about wrapping up the create repo process. Just a few more files to go and we should be ready to move forward. Saving primary, file lists, and other metadata. And now the process is finished. Let's echo the exit status. That didn't take too long. It wasn't so bad. And a DUCH of Yum reveals that it's still 2.5 gigabytes. However, we did mention that the new entry, the directory entry that is, the repo data entry, has been created. We can publish this data, or this data directory, back to the prime repository and then just update our yum.conf. That's one way to go about doing it. So for example, let's get a little creative and use tar. So let's just change things a little bit. Instead of RH5 Yum, we'll continue with RH5 i386 server as our source path. And then we need to publish the Yum repository using HTTP. So what we'll do is create a tarball out of the rep data directory, repo data that is, directory. We'll use bzip version 2 compression, so CJVF. We'll call it yum metadata.bz2 for the path repo data. This will create a file in the current directory, then we'll copy the file to the foreign server. And this will be ready momentarily. It's further attempting to compress an already compressed file. That's LSLTRH yum underscore metadata. It's 8.8 megabytes. So now let's SCP this file to the SUSE box, which is located at 192.168.75.100, into serve www.linuxcbt.com, RH5 i386 server. We'll specify the password. And it indicates that it's read-only because the remote system has the directory mounted. In fact, a mount will tell us that the ISO image is indeed mounted. So the easy way to fix this issue would be to create a new structure, yum, and then copy the files on the remote system and then unmount the ISO image. So let's copy it into RH5 yum. Then we'll have to change our configuration slightly. So this will copy into yum, and then on the remote system, in the interest of saving time, we'll copy APVF i386 server, and in fact we just need the RPMs, so no directory preservation. Start RPM to this directory. This will copy the 2.5 gigs very quickly, and then we'll update our nodes once again. Instead of i386 server, because we forgot we earlier mounted the ISO as opposed to copying it, it will be RH5 yum. We'll just confirm locally that the yum.conf file is in place. So let's nano etc yum.conf, and it is indeed RH5 yum. So the original path still applies. we'll be referencing RH5 yum as opposed to RH5 i386 server. And then we'll extract in RH5 yum the repo data file. So while this copies, let's open yet another session to the SUSE box from one of our empty windows. We'll SSH to 192.168.75.100. It will prompt us for authentication. Then we'll navigate to serve www. Again, we're doing all of this because Apache is running on the SUSE box and serving content from serve www.linuxcbt.com. So it just makes it easy for us instead of having to set up Apache on the local system. So here's the yum directory with the RPMs that have been copied, but there's also the yum metadata file. So let's tar x jvf yum underscore metadata, which will recreate the repo data directory and its file list and other XML files that the yum client will reference. So now an LSLD of repo data reveals that it's there. And so long as the web server is able to read the directory, it doesn't have to own it, we should have no problems accessing it from the yum client. Let's take a look at the total space occupied, and 2.2 of 2.5 have been copied. Local disk I/O copy is always faster than across the wire, so this will be done momentarily, at which point we can finally test yum from a client perspective to install a package. Let's say, for example, locally we'll install GFTP. So let's ensure it's not installed. RPM query GFTP, and it's not installed. Let's confirm, and it's now 2.5 gigs, which means the copy process should be over. And it is. So now that we've copied all the files, let's just ensure that our yum.conf configuration is complete on the first server. Now we've set the base URL. There are two more variables that we need to set before we forget. And that's an ID, a unique identifier for this repository. And you can use any string, but we'll just use a numeric 0001, as well as a name for the repository. We'll call it linuxcbt SUSE1. Let's go ahead and paste this, and we just need to point to the top level directory where the repo data can be found. That's the important directory to point to on your HTTP server. So on our local system, linuxcbt serve1, we'll nano etc yum.conf and be sure that we have that in addition. Then we'll remove the last item. And now we should be good to attempt to search for packages. So how about searching for GFTP, that is? So yum usage 1, search for packages. For example, yum search GFTP will search for GFTP from the repository after having set up the repository. Let's navigate to the shell and give this a try. This will attempt to set up the repository with all 2159 packages. And by the way, if you make changes to your repository, rerun create repo to update the XML files. RHN support is disabled. However, this first or 0001 repository is in the process of being set up. And there it's found GFTP 2.018-3, and it tells you it's a graphical FTP client. A search allows you to perform a search, doesn't install it for you. However, to install a package, use yum install. So install package, or packages, we'll install a couple of them. Yum install GFTP is one example. Let's give this a try from the shell. And this will prompt us for installation momentarily. Sort of works like apt-get in the Debian environment. We'll indicate Y to install, and momentarily we'll have the package installed. Now it tells us that the public key for the RPM is not installed. We've yet to import it, and that is true. Let's grep IGFTP from the query list, and there it shows that it's failed because we don't have the public key. But this we can override. However, it makes sense to import the GPG key so that packages can be confirmed. Let's show you where that key is. Instead of i386 server, let's navigate a level up, and in here you'll find the RPM GPG key. This should be imported to the local system so that packages can be confirmed. And here it is for the release of the software, so let's copy link location and import the key using the RPM command, followed by the import option, followed by the path to the key. To import it, we'll echo the exit status, then RPM query all GPG pub key, and this returns the public key. So with that said, let's attempt to reinstall the package. Let's just copy, prior to doing so, the fact that we imported the public key, the GPG key. So install packages, and we should just note, requires Red Hat GPG key for RPMs. So to import that, we execute RPM import from our server. Now let's try yum install GFTP again from the shell. And there's also an optional way to indicate yes to all prompts, and that's to indicate -y and as an option. And it'll just supply the Y option so that we're not prompted. This will go ahead and install GFTP. It reads the metadata from the repository, downloads it, and momentarily you'll see the traditional hash marks. And this tells us that it's complete. Let's echo the exit status. Then let's RPM query all, or just query GFTP directly, and there it is, it's installed. Now how about package removal using yum? Yum, yes to all, remove, and the package name, in this case GFTP, will remove it. And then we'll confirm momentarily using RPM to query the database. So yum is a front end to RPM, which works with repositories. And we'll just go through our history. It's no longer installed. How about installing multiple packages simultaneously, such as GFTP, DHCP? Let's query for DHCP using RPM. We'll query all, grep DHCP, just to be sure we don't have the server installed. And this searches the 929 packages before producing output. And it has the V6 client. So let's go ahead and yum install with the Y option GFTP DHCP, and this will take the two packages from the command line, read the metadata, and then attempt to set up both packages. It knows the sizes of each, and it's installed both. RPM query all, or RPM query directly, since we know the name, returns DHCP and GFTP. So to install multiple packages, it's straightforward. Install GFTP DHCP installs two packages. And you can remove one or more packages similarly. Now there are many yum options. Just execute yum help, and you'll see that in addition to install or remove, there are many other things you can do. A local update, local install, shell, what provides, search to help you search for programs, check update, which will check to see if there are any updates to existing packages, and so on. Now we've covered the local system. How about the remote 5.1 system, Linux CBT Serve 4? How about setting up its yum repository? Well, SSH is root over to 192.168.75.199, so that this system can also take advantage of the repository. We'll nano yum.conf, and then set up a repository as 0001. Can be any name you'd like as long as it's unique. The name will be Linux CBT SUSE1. You need to name it because you can enable or disable repositories from the command line. And the base URL is equal to the following. Now let's try to, on this system, after having queried GFTP as well as DHCP, install both packages using yum. So we'll yum install with the yes option, DHCP as well as GFTP. This will set up the repository from the HTTP server, which happens to be SUSE. And again, it says the public key hasn't been imported. Again, it's important that you do so that the packages can be confirmed. So let's import it into the remote systems database, into its RPM database, echo the exit status, and then attempt to set up using yum the two packages, DHCP and GFTP. There they are. The hash marks look successful, and then we'll RPM query just to be sure. Ditto for GFTP. Which GFTP reveals successful. So yum's installed. We can do additional things as mentioned, such as checking for updates, which also means we can populate our repository with items. Our repository is located in the yum directory. This is the repository, and as we get updated RPMs from Red Hat or elsewhere on the net, we can place them in this directory, but we need to run create repo to update the XML file, because the yum clients consult the XML files in the repo data directory as opposed to each RPM. So when you make changes to a repository, update it, but generally changes aren't frequent. And this can all be scripted out, of course, such that if you're hosting the yum repository on a Red Hat server, or if you've installed create repo, let's say on a SUSE server, when you pull updates down with your automatic process, you can update the repo data directory by running create repo as one of your steps. So that's a little bit about setting up and using yum in terms of installing and removing packages from the system. Again, to remove the packages, yum remove, and the names of the packages, GFTP, DHCP, will remove the packages from the system, and it will not prompt you because we indicated the Y option.